Hello again. Thanks for staying with us. This portion of our demonstration is directed to the manner of application and structural integrity. I mentioned before that silt fence is more than just a fabric. It's a system made up of fabric, post, method of attachment, and the proven post spacing. It's a system and should be tested as a system. The fabric should meet the efficiency requirements of the NPDES program, and the system should also have the structural integrity to withstand loading to the point of overflow and the test of time. With this test, we will demonstrate the application to the post and horizontal loading. Before we start, I want to introduce Jason Jones, our sales manager, and he'll be helping with this demonstration. Jason, if you'll help me with the fabric. This is a pass load stapler. Shoots a 1/2 inch by 1.5 inch staple, and it works very good in the field as a portable device should you need it. This device you see behind us is kind of like a structural table. We made it up so that we could demonstrate this method of attachment, the strength of the post, and just gives us something to demonstrate our procedure in our attachment. So bear with us a minute. These posts are 1.5 inch by 1.25 inch oak posts. They're 4 foot long. They slide up into this frame 24 inches, and it simulates 24 inches of silt fence outside the above ground. But we've got to do it horizontally. This is our belted silt retention fence. It's got an internal scrim. It's got a line on it that actually shows the men in the field where the clean out point is. And we're going to stretch it over these posts, and we're going to staple a bonding strip on it. A minute. This is a bonding strip. It's actually about 3/8 of an inch thick, 1 inch wide, 24 inches long. And it sandwiches the fabric between the post and the bonding strip. And what we do to simulate loading is Jason's going to actually sit on this, and it simulates a horizontal load in the field. And we also want to point out something. A lot of times in your woven fabrics you'll get a little small brush point through it one day, and it may be an inch hole. Next day you come back and you find it and it's 6 inches. And a lot of times the ravels the strands just unravel. But we're going to cut some holes in this. We're going to show you that under pressure it doesn't unravel. If the camera can zoom in on some of these holes, we can show you some of this. But the pressure doesn't ravel and the fabric doesn't pull back under the bonding strips. Now what this does for you, when you get a pressure point in the field, like on a large J-hook, you get a pressure point, and typically on fence that's hung on the hog rings, it pulls that slack down the hill until it gets enough slack, tears out the hog rings, and the fabric falls on the ground. This actually gains its strength by all the posts in the system because the fabric doesn't move on it horizontally. But we've got other issues in the field. A lot of times you've got people out there that are not qualified labor, and they may actually put this stuff in upside down. we're going to simulate that for you. And it also kind of shows off the method of attachment. But Jason, if you'll sit back on this, even if it's put in upside down or backwards in the field, the fabric don't tear off the post. Now, how many times have you seen fabric laying down on the ground and the wire still standing up there, or the support system standing up? This is a renewable resource that rots in the landfills, and it doesn't use any of our ores and things like iron. And a lot of times, we're going to do one other demonstration for you. We're going to flip this table upright and spin it around so that more simulates silt fence. Now, if you've got a tree in the field or a limb or whatever that falls across your silt fence, we're going to simulate that for you also. Now, even with that, with the amount of pressure, down pressure, you've not torn off the post. It's sagging a little bit and it's stretched a little bit, but if you'll just think about it, anything from these points on in the system is still tight and still upright. It didn't strip the whole thing down 4 or 5 sections like you see off of woven material or stuff that's hung onto the wire. So you may lose your center point here, and you may have to repair a section where a tree falls on it, but you don't have to repair your whole system. And guys, we have demonstrated the flow, efficiency, and structural capabilities of the belted silt retention fence. We hope that we have proven that value is in the specification. We don't claim to have a silver bullet that can solve all your sediment control problems. We do think we can help with some. Installation is another issue. It doesn't matter how good the product is if it is not installed correctly. It's all about choices. You can choose for yourself or take a chance and let someone else choose for you. Please visit our website at www.siltsaver.com for this and other sediment control tools. Thank you for your patience and your time.